did. And I'm going to do it again if you're not careful. Okay. All right, number 2. We're going to expand the following. Now, what that means is use our properties to pull them apart. So ln xy, now you're going to separate that and make 2 logarithms. When you pull it apart, it's going to come apart as an add, right? Multiplications come apart as additions. Additions go together as multiplications. So that's the first one, that's easy. How about this? Log x minus log y, that's beautiful. That's perfect. That's perfect. Oh, how about this one? Now we need to do this in 2 steps, okay? So the first step is let's pull them apart. So we'll have the log of x cubed minus the log of y to the 4th. Now, is everybody keeping up with that? Got it?
And then you gotta move.
Then you gotta move the exponent, so it'll be 3 log x minus 4 log y. So step 1 is we pull it apart. Step 2 is pull off the exponents. Oh my goodness. What is going on here? Oh, Evan, I heard something good there. You looked at that 5th root and said, wait a minute. A radical means the exponent is a fraction?
Yep.
And what fraction is a 5th root? What power is a 5th root? Tanner?
It's 1/5.
It's 1/5.
Since it's for both, does that mean it's a coefficient for both?
Yep. It's going to be a coefficient for both because it applies to both of them. Since the radical is over both of those letters, it's going to be a coefficient for both. So it's going to be 1/5 log x plus 1/5 log y. Remember, since these are being multiplied, when you pull them apart, they become an addition. And like Tanner said, because the radical is over both of these, they both get the 1/5. Emma, you paying attention? Okay. All right, how about the next one then?
1/4 log x minus log z.
Okay, what did you say, Evan?
1/4 log x minus, would that be log z?
It would be log z.
Okay.
That is absolutely perfect. Now, he went straight to the answer. I don't know how the rest of you do it. If you can process all that, that's awesome. What's happening here is we have a 4th root, and a 4th root means a 1/4 power. But this time, the root only goes with the x. So that the x is going to have a coefficient, but the z is not. Does everybody see that?
Yep.
Now, when he pulled them apart as a subtraction, because this is a divide, and divides come across as, or come apart as subtractions. I think that's perfect. Maddie, does that all make sense to you? You guys just nod at me and hope I'll shut up. Here we go. What about this guy? What do you think is going to happen here?
You'd have 1/5 on both sides because the radical is
The one, this is a 1/5 exponent, so everybody's got to remember that. That 5th root means 1/5 exponent. And since it goes with both the x and the y, when I pull them apart, they're both going to have a 1/5.
Yep.
And since it's a division, it's going to be a
minus.
subtraction. So 1/5 log x minus 1/5 log y.
Yep.
All right, 2 more. Oh, this one's a little bit tricky. We'll see if we can figure out the tricky part. All right, what do you want to do?
Take the exponent and equals. Okay. I do it all messed up.
Okay,
So take the 2,
okay,
put it log x, then
okay,
2 log x,
okay,
plus log 100.
okay, that's right. He did that exactly right. He said this is going to be log of 100 plus 2 log x. Now, what I want you all to pay attention to is, see that exponent? That does not go with the 100. That only goes with the x. If we'd had parentheses, then it would go with both.
Yep.
But as it is, it only goes with the x. So he pulled it apart as a plus, because this is a times, and he put the 2 in front of the x. Now here's the tricky part. This is really tricky. We're not done. This right here simplifies.
Log 2. Log 2.
The reason that simplifies is because the base is 10. And so this is saying, if you just look at this part right here, just this part right here, it's saying 10 to what power would be 100?
10 to the 10. I mean, 10 to the
2.
10 to the second. So the value of this expression right here is 2. So the answer to the problem is 2 plus 2 log x. The only reason we were able to do that is because 100 is a power of 10. If this had been like 90, I couldn't do that. But because that's a power of 10 and my base is 10, that simplifies. Tricky, tricky problem. Everybody in the room should be able to get this far. Only the super duper math people are going to go this far. That's tricky.
Is it going to be a quiz question? Or a test?
Might be a test question. But we'll practice more, obviously, before then. But that could happen. All right, there's one more. Let's see what happens on this one. ln 30e cubed. This is kind of the same thing. What's it look like when we split it up? Pay attention. Who gets this exponent? The 30 and the e?
No.
Yeah.
No.
Nope.
Just the E.
Just the e. So ln 30 plus ln e cubed.
Yes.
And what about that 3?
3 ln e.
Yep.
Can't that be?
It can. This is another tricky one. Let's look at ln e. ln means log base e.
Yep.
What does that equal? E to what power gives you e?
1.
So this just equals 1. So that just equals
3.
3. I got the hiccup. Shoot. So ln 30 plus 3?
Yep.
And this will be on non-calculator? Because that's,
Yep.
yeah.
This is no calculator. Yep. Yep. Now the next section is going to start the calculator part. Hardcore. So we'll want to have a calculator with us on Monday because we're starting that the real calculator stuff.
It's only Tuesday.
I know. What we're going to do now is a little bit of practice. Someone say we can have Now, you guys have 5 days to sleep. Get your head up, look alive. How in the heck you can sleep during this excitement is beyond me. Huh? Could you really? Don't you think? I don't know. Lately, I've been just waking up and can't wait to get to school. I've had so much exciting stuff going on. Oh, James Wayne, wake
Mrs.
up,
Ford,
wake up,
you
wake
need
up.
another one?
Oh, did I not give you enough? Okay, did everybody get one?
Yep. Wait. Is this the practice quiz?
This is more like review.
Oh.
We're gonna have, on Monday, we'll have a practice quiz. Or next time I see you, I think Monday, we'll have a practice quiz and then the next day we'll have a quiz, okay? But this is just a little bit of review because I wanna make sure that we are all kind of staying, we've crammed a lot of information in the last few days and I wanna make sure that we're not losing any of it. So, this is some old quiz I found in my notebook and I thought it would be good practice. So, what do you think? Number 1, simplify. I didn't even put any directions on here. Simplify this. This is a trick question because almost everybody is going to see that -4 and think 1 over. And it is. But only the x gets the 1 over. So it's 5 over 1 times 1 over x to the 4th.
Yep.
So the answer is 5 over x to the 4th. Negative exponents mean 1 over, right? Flip. But only the things that have the negative exponent flip. 5 does not have an exponent, so it stays 5. This guy flips. That's a GTQ, guaranteed test question. All right, 16/9 to the 1/2.
4/3.
What does a fractional exponent mean?
Radical.
A radical. And since that's a 2, it's a square root problem, right?
Yep.
Square root of 16, square root of 9. If you are struggling with that, you need to practice in these next 5 days. Because this has to be kind of automatic. That when you see a 1/2, you think square root. All right, what about this one? This is kind of big.
Would you get everything in the parentheses first, then work your way up?
My personal preference is, yes, I would simplify the inside first.
Okay.
Can you get the right answer if you don't do that? Absolutely. So you have a choice. Me personally, I think it's easier to simplify this. So I'm going to ignore that for a moment,
Yeah.
and I'm going to simplify this. So simplifying in there, the 2 and the 3, nothing happens to.
Nope.
See that negative though?
It goes up.
He goes up. So I'm taking 2 up,
Plus.
but there's already 3 up there.
Yeah.
So that's going to be 5.
Yep.
Now I have, looking at y's, I have 5 over 1. So when I cancel, I'm left with 4.
Yep.
We're just going 1 letter at a time. Now, that's to the -2nd. So what does the negative do?
Flips it.
Flip it. So turn it upside down. The negative simply turns it upside down. And then I square everything. Now watch it when you do that. I mean, obviously 3 squared is 9. 2 squared is 4. But be careful here. When you square x to the 5th, that means x to the 5th times x to the 5th. That's x to the 10th. Very good. Very good. We don't square exponents. And then this would be y to the 8th. Beautiful. Beautiful, beautiful, beautiful. Okay, so 27/8 to the negative 2/3.
Get A over 27.
First things first. Guys, see the negative? It tips you upside down. It flips you. Ava, what does a 2/3 exponent mean?
Multiply.
Oh my goodness gracious. Ava, what does
Square root.
a fractional exponent means a radical? That is right. And since the denominator, Ava, is a 3, this is going to be a cube root problem. So it's a cube root squared.
You end up getting 4 9s.
What is the cube root, Ava, redeem yourself. What is the cube root of 8? 2. What is the cube root of 27? 3. Now I'm going to square that because of that 2 that was in that exponent there. So 2 squared is?
4.
And 3 squared is? 9. Now, I wrote out every single possible step there. Some of you are going to need to do that, and that's fine. But we need to come up with 4 9ths is the answer. Somebody else has the hiccups.
Sorry.
That's okay. I get them all the time. All right, 16 to the 1/2. What's that mean?
Radical.
Means the square root of 16, so that is 4.
Yep.
What does 9 to the negative first mean?
1 over 9.
1 over 9. So I am multiplying 4 over 1 times 1 over 9.
4 9.
4 9s. Colin, what do we think when we see 100 to the 3/2?
Cube root.
Not cube root.
A radical.
It is a radical, but it's a square root. Because the denominator tells me which root, right? So it's going to be the square root of 100 cubed.
10 to the 3rd.
Square root of 100 is 10, and 10 cubed is 1,000. Now, this time, this problem's different than the first one. Because this time, the whole thing has the exponent. So the whole thing is going to be under the radical, right?
Yes.
Right?
2x.
So the cube root of 8 is
2.
2. And how many x's if I split 15 up into 3 groups? That's right, x to the 5th. You are perfect. 2x to the 5th. Nicely done. One more on this side. Here we go. Let's simplify the inside, even though we don't have to start that way. 25 or 36 and 25 do not reduce.
Yeah.
How about the x's?
X squared up top.
Perfect. Ooh, watch the y's. They're both negative. So 3 are going to the top and 5 are coming down.
Yep. And then you bring the 3 down, which would be y squared.
Y squared on the bottom.
Yep.
Was that too fast? Everybody follow that? To the 1/2. What does 1/2 mean as an exponent? Square root? Isn't that what 1/2 means?
Yep.
Square root of 36?
6.
Square root of x squared? X?
X, yeah, just x, yeah.
Square root of 25?
5,
Square root of y squared?
just y.
There's your answer. Beautifully done. Beautifully done. All other side as we can. We may have to finish this next time. This is some old practice quiz. This is not your real practice quiz. We will do that on Monday. This is just practice. Log base 5 of 25 equals x. Jalen says 2.
Yes.
Do you agree? Because hopefully what you're all thinking is 5 to what power is 25? And that is 2. Loop de loop.
D is 3.
And you've already figured out this means x squared equals 9, so x is 3.
Yep.
Evan's on fire. 7 to the negative first equals x, and 7 to the negative first means, Bo, are you paying any attention? No, you're not. You're writing on your hand. Come on.
7.
No, it's 1/7. 7 to the negative first is 1/7. Remember, we flip it.
D is 2.
D is a hard problem.
Oh wait, no.
Yeah.
3.
D is a hard problem because we had to do something with that 3. I don't know, what do you think?
You gotta bring it.
2x to the 3rd equals 4?
No.
Log.
This, a number out in front of a logarithm
X equals
is an exponent. So this is really
4 to the
log
4
base
to the
2
4
of
cubed.
4 cubed, and 4 cubed is
64.
64. One of the things we talked about today was
So there's
that a
actually 8.
coefficient in
6.
front is an exponent.
Yeah.
So that's not a 4, it's actually a 64.
Yeah.
So 2 to what power is 64? Now, I think it'd be awesome if you knew that, but if you don't, you can over to the side just start multiplying, right?
6. No.
So 2 times 2 is 4,
It's 8.
times 2 is 8, times 2 is 16,
Yeah.
Oh, no.
times 2 is 32, times 2 is 64. So that many, 1, 2, 3, 4, 5, 6. So x is 6. If you said 6, you were right, but some people were saying other
8
numbers.
times 8 is.
Okay, we're done. Everybody good with that? A little more work involved there. E is simple. What's the answer to E? 64. 8 to the second. Ooh, F is hard.
-2.
Very good. Would everybody agree that F says 4 to the x equals 1/16?
Yeah, it would be -2 because the 1/16.
Okay, so we're thinking lots of things. Our minds are just going 100 miles an hour. This is 1/.
Yeah.
The only way you can get 1/, is if your exponent is negative, right? It's got to be negative. Now, I started with a 4, but I got a 16. So that's got to be a 2, right? 4 squared. And the answer is -2. You got to think. Oh, anybody know the answer to G? This was on a problem in our notes. We talked about it, but didn't really spend a lot of time on it.
The 8 and the log 8 cancel.
Yep, so the answer is just
3.
3. The answer is just 3.
One
Huh? Why do they cancel? Because exponents and logarithms are inverses of each other. So when you put both of them in the same problem, it's like multiplying by x and 1/x. They cancel each other out. So anytime the base of the logarithm and the base of the exponent match. So you have a log base 5 and a base 5 here. It's always gonna be whatever that extra number is. So with that in mind, what do you think H is? 9. Because the 7s are gonna cancel, right?
Yep.
So X has to be 9, perfect. How about I?
3.
Oh, very good, because you remembered that the base, even though it's not written there, is 10. So 10 to what power was 1,000? Perfect. J? These always look so scary, but they're so easy.
6.
What?
6.
6? That's exactly right. You do that a couple of different ways. Yeah.
When do you multiply like the beginning number? I feel like we did that in our notes. Like you
We
do the problem.
actually did, and that was, they weren't equations, so they didn't have it equals, and we didn't know that that was actually an exponent at that point, so now we're not gonna do that anymore, we're gonna pop it up as an exponent now. Unless we can divide it out. Sometimes we can divide out. Those problems we looked at were not exponents. I mean, were equations, I mean, they weren't equations. Okay, whoa, we gotta finish this one. This says e to the x
6.
equals e to the 6th, so 6 is the answer. And it's that cancel thing again. The base of the exponent and the base of the logarithm cancel, so the answer is just 6. Okay. Whoa, we are not done, folks. We still got time. Stop it. We're going to simplify. What's 3/4 to the negative second?
9 16.
It
No,
flips-
16
it
over
flips
9.
it
16
over.
over 9.
It flips it over and squares it, so 16
16 over
ninths. B. We're not leaving until we're done. You
27
need to
over
add
8.
down. So it's the square root of 9/4 cubed.
Yep.
The square root of 9 is
27
3,
over 8.
2, cubed, 27 over 8. Perfect. And then the last one, come on, you might as well just pay attention, get it done. Any simplifying I can do inside. It looks like I can cancel 4 over 3, x to the 4th,
Yep.
and y to the 11th, because the 3 on the bottom are coming up. Now I'm going to square the whole shebang. 16 9.
Over x to the 8.
8.
And then y to the 21st.
22nd.
Or 22nd.
Yep. Perfect.